Okay, here we go. So factoring. Remember how to factor. If we have x squared plus 6x plus 8. To factor just the normal trinomial there, we put two sets of parentheses. We do what? Split up the first term, x and x. What of these two? I need the what of those two? The factors, 1 and 8, and 2 and 4. And I have to decide which of these factor pairs add up to this. Which ones add up to that? So I go plus 2 and plus 4, multiply to be a positive 8. They have to multiply to be this, add up to be this. So if I had sine squared of x plus 6 sine of x plus 8, it would just be sine of x, plus and 2 and 4, right? You're just replacing an x with a trig function and just factoring normally besides that, okay? So if we had 4x squared plus x minus 3. 4x squared plus x minus 3. When you have a first term coefficient, you can't use these same rules that we use for this. Okay? So when we had a first term coefficient in algebra 2, what did we do? We used the AC method. Wheeldryer taught you the AC method where you multiply this times this. And what do you get? 12x squared, right? And what are the factors of 12x squared? Well, 1 and 12, 2 and 6, and 3 and 4. I guess we're not worried about the x's, we're just worried about the numbers, sorry. Yeah. So, which of these make the middle term? 3 and 4 if 3 was negative and 4 was positive, right? So then what we do is we take the power off this first one and write 4x and then minus 3 and then 4x plus 4. We just take the power off of this one and just write it in both of those places, and these two we write here and here. Now, we take out the greatest common factor, so we divide by the greatest common factor. The greatest common factor of here is 1. The greatest common factor of here is 4. So it's 4x minus 3 and 1x plus 1. If you would FOIL this out, 4x times x is 4x squared. Plus 4x minus 3x is plus x minus 3. It checks. Okay? So if that works like that, if I had 4 tangent squared of x plus tangent of x minus 3, it would just factor into 4 tangent of x minus 3 and tangent of x plus 1. Okay? So the only difference is I'm throwing a trig function in where there's a variable. So let me start out with them being trig functions now. Oh, sorry. Okay, so let's say we have something like this. Tangent to the square root of x minus 3 tangent of x minus 28. How would you factor that? What do you start with? What do you write down first? two sets of parentheses. You split up your first term into tangent of x and tangent of x. If this is a negative, are the signs going to be the same or opposite? Opposite, because they have to multiply to be a negative. So one's got to be a positive, one's got to be a negative. What are the factors of 28 that have opposite signs that add up to 3? 7 and 4. Now what goes with the positive, the 7 or the 4? Because they have to multiply, they have to add up to be a negative 3. So positive 4 and a negative 7. Factoring with trig functions. Okay? Two secant squared of x plus secant of x minus 10. What's different about this one compared to the last one? It has a first term coefficient, right? So I have to use the wheel dryer AC method. 2 times negative 10 is negative 20. Factors of negative 20 are 1 and 20, 2 and 10, 4 and 5. We need to add up to about positive 1, so I have to use a negative 4 and a positive 5, right? So I write 2 secant of x, because I dropped the power, minus 4, and 2 secant of x plus 5. Greatest common factor of this? 2. Greatest common factor of this? 1. So it's secant of x minus 2 times 2 secant of x plus 5. And if you'd FOIL it, you'd get the top. Okay? All right, we're not done yet. We got a lot left to go. Cosine squared of x minus 9 sine squared of x. Cosine squared of x minus 9 sine squared of x. When you have two terms separated by a minus sign and they both have square roots, it's called difference of squares. When you have differences of squares, it's two sets of parentheses. Split up the first terms, which is cosine of x and cosine of x. Then the signs are opposite. You have a plus and a minus. And then you split up the last terms. How do you split up the last terms? 3 sine of x and 3 sine of x. 3 sine of x and 3 sine of x. So you'll have differences of squares factoring today. Now, this one you could use the AC method if you wanted to, but if the first term has a square root and the last term has a square root, it's a perfect square trinomial. One quantity squared. Okay? You take the square root of the first, which is 2 tangent of x, the sine of the middle, which is minus, and the square root of the last, which is 1. If you would write it twice in FOIL, you'd get this. So it's the square root of the first, sine of the middle, square root of the last. That's a perfect square trinomial. That's only if the first and last terms both have square roots. All right. Sine of x cosine squared of x plus 5 sine of x cosine of x plus 6 sine of x. Ew. Ooh, Ella got it right off the bat. Since all of them have a sine of x in them, what should we do? Well, we should factor out a sine of x. And then the rest of it is just kind of normal everyday factoring. So it's sine of x times 2 sets of parentheses, cosine of x, cosine of x. Two factors that multiply to be 6, that add up to be 5. 3 and 2. Okay, so be ready if you see something kind of weird that looks like it's tough to factor. Look and see if they have a common factor among all of them. And then if we have 4 terms, such as all right, 2 secant squared of x plus secant of x plus 2 secant of x tangent of x plus tangent of x. If you have 4 terms, factor by grouping. Group the first 2, group the last 2. What comes out of the first 2? Secant of x, and you get 2 secant of x plus 1. What comes out of the last 2? Tangent of x, and you get 2 secant of x plus 1. Now, if these match, they go in their own set of parentheses, but you don't square it because of the addition going on. And then whatever is in front of both of them go in its own set of parentheses, secant of x plus tangent of x. You take this sign, and this. So it's secant of x plus tangent of x times 2 secant of x plus 1. Okay? So that's the different factorings that we'll be doing. So on page number 172, we're working on 23 through 36, all of them. I am going to give you probably 25 minutes to work on this because it'll take a little while to work on these. So take about 25 minutes, work on this, and then